Right now, as you're watching this, there's a crazy collaboration going on between your eyes, ears, and brain just to make this moment possible. And each of those organs, they rely on millions of cells working together in perfect sync. Those cells are built from molecules, DNA, proteins, all the good stuff. And those molecules, they're made of atoms. But where did your atoms come from? They were once floating in a boiling, toxic soup, somewhere in Earth's first oceans. So, how did that soup end up becoming you? I'm Core, and this is Link to Think, where I dive into the biggest questions that keep me up at night, and where we explore the entire human story, from the birth of Earth to right now, not just in order, but from a whole new angle, by tracing the synchronicity of events. Today, we're diving into the greatest mystery of all. How did lifeless matter give birth to life? Picture this: nothing but rock and fire. No life, no brains, no intentions. Just rain, lightning, and oceans steaming with chaos. But from the deadest scene you can imagine, something started to react. It didn't have a brain. It didn't have a heart. It didn't even know what it was doing. But it was the first step toward life. How can something that isn't alive create something that is? 4 billion years ago, the primordial soup and the birth of simple molecules. Back then, Earth was a mad kitchen. Volcanoes, toxic gases, ultraviolet radiation from the sun, ebb and flow, endless oceans, boiling hot, lightning. That's the full recipe. What else could you ask for? It just needed time. The planet was packed with atoms, and they'd landed in the perfect chaotic mess to start reacting. We call it the primordial chemical soup. In this soup, atoms smashed into each other non-stop, and over hundreds of millions of years, from billions and billions of random aimless collisions, simple molecules began to form. Things like water, ammonia, methane, carbon dioxide. But why did it take so long? Because nature wasn't following a plan. It was just running chemical trial and error on autopilot. Most combinations? Useless. Some lasted only seconds. But every once in a while, one stuck around just a little bit longer. And that little bit longer, sometimes it was enough to change everything. But it's like nature wasn't satisfied with just making simple molecules. It wanted to try something more. And this soup, it had something else too. Energy, relentless, wild, unforgiving. When molecules got complicated, that energy, combined with raw materials and solar radiation, triggered thousands of new combinations every single day. Combinations that kept forming, breaking, reshaping, until eventually more complex molecules emerged, with branching structures, ring shapes, and higher chemical reactivity. This process took around 300 to 500 million years. Why so long? Because going from simple to complex had no blueprint, no goal, just probability, rolling the dice, again and again and again. The birth of organics. Among all these molecules, one group had something special. They contained carbon. Carbon could form 4 bonds with other elements, build chains, loops, branches, and create molecular structures that no other element could pull off. Why? Because most elements either form fewer than 4 bonds, or, even if they can make 4 or more, their bonds don't last. They fall apart. The molecule breaks down before it can really be anything. But carbon? It had 2 killer features. 1, it could form strong, stable bonds with a wide range of atoms. 2, and it could make up to 4 connections at once, which meant endless variety in how it combined. Put those 2 together, you get Tons of stable, diverse molecules. You've probably heard scientists say life is carbon-based. Well, this is where that idea comes from. We call these carbon-containing molecules organic molecules. Some were super simple, like methane. Others were a bit more complex, like amino acids. But they all had one thing in common, a carbon backbone. And just to be clear, they weren't alive. Not yet. And here's the twist. Not all of them may have formed on Earth. Some of these organic molecules might have hitched a ride on meteorites from space. Yeah, some scientists think that life's ingredients may have been delivered to us. We've even found amino acids inside certain meteorites. But it doesn't really matter where they came from. What matters is they were here, and they were ready for what came next. From organic to bio. Among all those organic molecules, some went one step further. They weren't just complex, they were active. What does that mean? Some of them could store energy, some could react with other molecules, and some carried a structure that looked like a message. We call them biomolecules. Amino acids, nucleotides, sugars, and lipids. They were the first biomolecules, the ones that, out of all carbon-based compounds, had the greatest ability to interact, react, and build. And right then, those molecules, unaware of everything, without knowing what they were doing, linked together and took the first steps toward becoming us. Biopolymers, the chains of life. Soon, these biomolecules began to form chains. We call these chains polymers, and each molecule, by becoming part of a polymer, created something greater than itself. The chains of amino acids became proteins, the chains of nucleotides became RNA, and the chains of lipids became the earliest cellular membranes. These weren't just chains, they were the beginning of something larger. Something that, with every new link, moved one step further from the lifeless and one step closer to being alive. RNA, the star of the polymers. Among all the polymers, one stood out above the rest. RNA. Why? Because it was more than just a complex molecule, more than an active compound, more than a typical polymer. RNA was a multifunctional organic polymer. It could store information, it could copy itself, and it could even trigger chemical reactions. In other words, RNA could act as both memory and enzyme, both the coder and the executor. That's why many scientists believe life may have started with RNA. It's not a living thing, not yet, but one of the most important steps toward becoming alive happened right here, with RNA. The final combo, protocell. By now, our story's polymers, alongside millions of other biopolymers, were combining, reacting, and dissolving in every corner of Earth's early oceans. But most of them were unstable, couldn't store information, couldn't interact with their surroundings, would vanish after a single reaction. Only a few, by complete chance, had just the right combination of traits, like a fatty membrane that could interact with the world, and a molecule like RNA that could store information and copy itself. And at some point, in one of those countless random combinations, a strand of RNA, and probably a couple of primitive proteins, got trapped inside a fatty bubble. A bubble built from lipids themselves. It wasn't a real membrane, it wasn't a full cell, but it was something like both. A semi-stable structure was born. We call it the protocell. Not alive, but not quite lifeless either. More like a bridge between chemistry and life. And maybe, for the first time on Earth, information and reaction stayed together, just long enough. It wasn't life yet, but it was just one step away. And here's something we shouldn't forget. Even though these polymers had the potential to form protocells, they also formed thousands of other combinations that never led to life. Only in some very specific arrangements, and under rare environmental conditions, did they manage to take a single step closer to becoming a real cell. And for that, we owe it all to one thing: time, and an environment that gave nature the freedom to try again and again and again, until something stayed. The birth of life. Over time, the combinations kept happening, and with each one, new molecules joined our story's protocell. Most of them had no real effect, but every now and then, out of thousands of random mixes, a few turned out to be useful. And when they merged with the protocell, they added new abilities. The ability to copy its information, to divide itself, to consume energy, and to keep going. Traits that, when something has them, we call it alive. And that's how life began. Not with a spark, not with a miracle, not by design, not with intent, but through repetition, and repetition, and repetition, and maybe just a little bit of luck. But this was just the beginning of life. In the next episode, we'll dive into the oxygen revolution and explore the strange question: did oxygen create life? Or did life create oxygen? And hey, don't forget to like and drop a comment. I personally read and reply to every single one. It really means a lot to me and the whole Link to Think team, and gives us the energy to keep making more episodes for you.